Good evening, chemistry kids. Got a short one here for the first podcast in Unit 6, which is identifying reactions as one of 5 types. Now, in this setup, we're going to be particularly easy because you get to see both sides of the reaction. But later on, we're going to be talking about how to identify the type of reaction, only getting to see the reactant side, so the left side, and not any of the products. And that's a little more difficult. So this one won't take as long because it's pretty straightforward when you get to see both halves of the reaction. The first type that we're going to look at is synthesis. And in a synthesis reaction, 2 single elements react to form one compound. So it has this as a generic equation. A plus X yields AX. Now, properly, this equals sign should be a chemistry yield arrow, but my iPad's really generic and I don't have any symbols on it, so you'll just have to excuse the equal sign. It's not proper chemistry grammar, but I'm sure we can work with it. And here's an example of a simple synthesis reaction where you have 2 elements, sodium and chlorine, forms one compound, sodium chloride. I don't want to get hung up here on the balancing where these twos came from. We'll be talking about that in more depth later. I do want to take a moment to remind you about chlorine and why as an element it's Cl2. So remember that we have a list of these elements. Brinkelhoff, and anytime that you have one of those as a single element, they come as a diatomic molecule, so you always have the subscript 2 on that. So store that away for a lot of these reactions. Decomposition reactions are the opposite of synthesis, and one compound reacts to form 2 or more simpler compounds. Now, these simpler compounds may be elements. We literally could have the reverse of the reaction that I just showed where sodium chloride decomposes into sodium and chlorine gas, but that's not always the case. It could be a compound that decomposes not just into 2 elements but into 2 slightly simpler compounds. We can see that with an example here. This is calcium carbonate, and it doesn't decompose into calcium carbonate and oxygen, but it decomposes into calcium oxide and carbon dioxide. So the key identifier is one thing on the reactant side and more than one thing on the product side. Single displacement reactions happen where one element displaces the, and this is a key word here, equivalent part of a compound to form an element in a different compound. And so it has the generic reaction A, this would be our element, plus Bx, that would be our compound, and the element displaces part of the compound to form a new element, and what was the single element is now part of a compound. So let's look at this as an example. So I can spot this as a single displacement reaction because I have a single element, compound, makes single element, and a different compound. And the key, as I mentioned in the previous slide, is that we're switching the equivalent parts. So I have to think about the charges of sodium and nitrate. They're +1 and -1. And now I have to think about what I know about copper. Well, it's a transition element, so I'm not certain of its charge, but I definitely know that it is a cation. And in this case, it's acting as the +2 cation. So I make sure that I displace the sodium and place the copper with the nitrate and have our sodium as the single element. That avoids me having a positive with a positive if I incorrectly paired the copper with the sodium. One last thing I'll leave you here with on single displacement is when they involve water, sometimes that can throw students off a bit. I'm not going to bother balancing this one right now, but we can see what I'm trying to illustrate without having it balance. and you can spot it as single displacement, single element, compound, single element, compound. Again, hydrogen is a member of Brinkelhoff, so that's why it's the diatomic molecule here, not just plus H. Although sometimes students get confused about this because the water is not being displaced in a manner that they would expect. This is often what students expect for a single displacement reaction involving water, where you get sodium hydroxide plus hydrogen. They split the water into the oxygen -2 anion and 2 hydrogen plus 1 cations, but this is not actually what occurs. Water displaces as if this is how it's composed, with hydrogen cation and hydroxide anion. And if you think about that, then I can say, I've got a sodium that's plus 1, so I'm going to pair my sodium cation with the hydroxide anion, giving me sodium hydroxide, not sodium oxide. So if you think you have a single displacement reaction and it involves water and you're not entirely sure, it might help to think about water as HOH, and that might help explain why it's being displaced in a manner that's maybe a little different than what you would expect. Double displacement reactions are pretty easy to spot, where you have two compounds and they just switch their ions. And again, we're making sure that we keep things away from any positive positive or negative negative. So the generic equation AX plus BY forms AY plus BX. They've just switched their ions. Here's my example. We have potassium iodide plus lead chloride makes potassium chloride plus lead iodide, and those all get switched up because positive, negative, +2, -1, positive, negative, +2, -1. So all the ions just got switched, and those are pretty straightforward and easy to identify. The last reaction type is combustion, and in a combustion reaction you have a hydrocarbon, so something with carbon and hydrogen. Normally it will have this as a ratio, unless it has some double or triple bonds, and then this will get altered a little bit. But anyway, the hydrocarbon reacts with oxygen gas, right there, to form water and carbon dioxide. And here's a quick example of that. Hydrocarbon, oxygen gas, carbon dioxide, water. So that's pretty easy to spot. So here are the 5 reaction types that we'll be looking at. There are some other ones out there in the world of chemistry, but we're going to be mainly looking at these 5 in class. So talk to you later.